Okay, here we have another rational equation. This one is much more difficult than just a rational proportion, and the reason it's more difficult is that there's that plus 1 being added to the left side. Anytime you have a problem like this, you're going to have to get rid of the denominators first by using the LCD method. What that really means is we're going to factor all the denominators on the left, factor all the denominators on the right, and then we're going to look at it and say, what is our LCD? So from our previous LCD section, you'd pick out here that the LCD is going to be x minus 7 times x plus 2. Now that you know what the LCD is, we're going to multiply it by both sides. And that really means we're going to multiply it by both terms on the left side and by the right side. When we do that, you can see in red is how we showed multiplying it by every term. And in doing that, on the very first fraction on the left, you can see that the x minus 7s are going to cancel, leaving us just 3 times x minus 2. Nothing cancels when we have the plus 1 there, but both the x minus 2 and the x minus 7 are going to cancel on the right-hand side of the equation, just leaving us with an 8. And that's what the LCD method does, is it gets rid of the fractions. So now we have just an equation with no fractions in it, and now we're going to have to use distributive property and choose a method to solve. In this case, when we use the distributive property, again, you can see we have an x squared term, so this is a quadratic. And this is going to be common in section 11.8. You're going to come out with a lot of different quadratics, and then you're going to be asked to solve. The good news here is that this one looks like it's going to be very easy to solve because there's no constant term. We can just factor and use the zero product rule. And so our solutions are going to be 0 and negative, or 0 and positive 6. Now my question is, going back, are any of those extraneous solutions? So when I check for my extraneous solutions, I'm going to go back and look, and it looks to me like both 0 and negative 6 are okay, because the extraneous solutions in this problem would have been positive 7 and positive 2. So there's our solution with a difficult one where we have to get rid of the fractions.